Okay, so on this question, we're trying to solve the equation, this equation. How do we do it? Well, what's different now in this section is we have an equal sign. This is a wall of separation. In fact, why don't I just put in the wall for extra clarity? That's a wall, right? We have a left side and a right side. So all of our thinking becomes left and right. Whatever I do to the left, I'm going to do the same thing to the right to keep the balance, right? Right now, the left and the right are equal. This equal signs mean they are the same. They don't look the same, but they are the same. They are equal in value, is what the statement is saying. So if that's the case, if two things are equal and you treat them the same, they're going to be equal afterwards, aren't they? So that's called the principle of equality, right? If two things are equal and you do the same thing to both of them, they have to be equal afterwards. And so all of our thinking is going to be that way. All right, so what are we going to do? Well, the first problem is we got these fractions, right? So what do you do? That's what this problem is all about. What do you do when you have fractions with an equal sign? That is the name of the game in this section. Fractions with an equal sign. Step number one, you multiply all the terms. Now, normally in the last section, it was all the terms top and bottom because we'd have like a big complex fraction, like minus 4 over x plus 7 over 4 over 3x minus 0, something like that, right? And I would multiply all the terms top and bottom. But now I'm going to do all the terms left and right. Left and right. Left and right by, I kind of ran out of room over there. On the left and the right of the equal sign by the LCD over 1. So I don't have a complex fraction. That was the last section. That was 8.5, where we had fractions over fractions, right? And we multiplied all the terms top and bottom, because in that section, all of our thinking was top and bottom. But now all of my thinking is left and right because I have an equal sign. There were no equal signs in the last section. So equal sign left and right. And you know what the LCD is, right? This is not the first time we've done the LCD. LCD is always one of each type of item under the bar, under the different bars, under the bar, and right? So just one of each type. So I look under the bar, okay, what I got? X here, I got 3 and X here. So you only need one of each type. Now, so I'm not going to repeat that X. I'm not going to take 2 X's or X squared or anything like that. I'm just going to take 1 X and 1 3. 3X. All right. And then what are we going to do with it? Well, we're going to multiply by it, right? So let's do it. So I'm going to go 3x over 1. I'm going to multiply there. And I'm going to go 3x over 1 like that. Isn't that good? Wrong. You know me, I like to do it wrong just so you won't. Right? What's wrong about that? I'm multiplying. All right, I did it, right? The LCD is 3x, right? Because x and 3x, you just take one of each type. So I took a single 3 and a single x. 3x, that's right. But I didn't do this. What didn't I do? All the terms. What did I skip? This guy. Don't forget him. It's a really, really common mistake to think, oh no, I'm just doing the fractions, just the fractions. No, you don't have that choice. Remember, we got to keep the balance. With an equal sign, you have to do the same thing to all the terms left and the right. Right? Remember the principle of equality. If the left side and the whole right side are equal, then you got to do the same thing to all the terms, so they'll be equal on the next line. All right. So watch out. Common mistake on that. Let's come on down. So what do you do now? Step 2. Cancel all denoms. That's the reason we're doing it, because we want to get rid of denoms. So this and this will cancel. What do we have left? 3 times negative 4. What happens here? 3x and 3x cancel. Bring down the 4. Minus, and then 2 times 3x. Right? 3x, the 1 doesn't do anything down there. So what is that? That's negative 12. And that's minus 6x. Look at that. Much nicer, huh? No more fractions. See how we get rid of the fractions on that first step? No more fractions. And then step 3, just solve it now. Now that you got rid of all the fractions, it's a piece of cake. I don't know. piece of cake, but it's much easier now that the fractions are out of there. So now just solve for x. So that we subtract 4 from both sides. You know what I mean by solve for x, right? X is here, and x is yelling out, I want to be alone. Get rid of all this stuff so I can be alone. This x over here on the right side, saying, I want to be alone. Get rid of this 4. Get rid of this -6 so that I can be alone. That's what solve for x means, get x alone. So subtract 4 from both sides, like so. Boom, boom. And we get, what's that, -16 equals -6x, right? -4 and -12, -16. And then last step, to get x alone, divide. And whenever you divide, divide by exactly what's next, the identical twin, same sign, same everything, whatever's next to x. Boom, and then that fraction can be reduced, huh? Divide top and bottom by 2. We always reduce fractions. That's going to be 8/3. And it's positive because 2 negatives make a positive. So there's our answer, positive. That's what they want up here. X is 8/3. That's the solving of the equation. That's the value of x that makes this equation true. I mean, if you plugged in 8/3 there and there, it would make the left side and the right side equal. It'd be a bit ugly. I don't want to do it, but that's what it is. It's the value of x that makes the equation true. When plugged in for x makes the left side equal the right side. So well, that last step, we just reduce the fraction, divide top and bottom by 2, and the 2 negatives made positive. So there we go. So when you have fractions with an equal sign, you multiply all the terms left and right by LCD over 1. LCD is 1 of each type of item under the bar. So 3x over 1, 3x over 1, 3x over 1, and then cancel all the denominators. Comes down to here, and then just solve for x. There we go.